So from what we saw on page 1, you have your different number systems, and we had to write out each of the number systems that each number was a part of. Here we're going to do a little bit different organizing. So you are going to put it in the, when they're in here, you're going to put it on the furthest one down that you can. So for instance, A is 7. 7 is a natural number, which also means it's a whole number, integer, and rational number. But since natural number is inside all of those other circles, we only have to put it down in natural numbers. So instead of listing them all, you're just putting it in the one that it is the furthest down. Here we have negative 36 over 12. Again, when you see a fraction, it's very tempting to just put rational number right away. However, we should know that this divides to negative 3. So negative 3 is not either of those, but it is an integer. So again, that also means rational, but we will stick with integer because integer is within the rational numbers. C, again, you can use your calculator to check for the square root of 36, or hopefully you know that 6 times 6 is 36. The negative sign is just out in front, so that stays. So negative 6 is what we're actually looking for letter C. That makes it an integer. So C would go in integers. Pi should be our favorite one because we automatically know that it is an irrational number. E, 6 and 48 hundredths. When you say 48 hundredths, that means 48 over 100, so that's a fraction. Again, anytime you see a nice decimal, that automatically means it's a rational number. It cannot be any of these three down here. Letter F is negative 2. Again, neither of these two can be negatives, so negative 2 is an integer, which again means it's rational, but we'll just put it in with integer. Letter G is negative square root of 10. There is nothing that you can multiply by itself to get 10. 10 is not a perfect square. 36 was a perfect square. So this is going to be an irrational number. Again, you can type it in your calculator and see that it's just a crazy decimal. H is 0. Again, 0 is the only number that is a whole number, but not a natural number. So the only time you'll have something in the whole number circle is if you have 0. Letter I is 2 and 1/6. That's automatically a fraction, so that will put us into the rational numbers. If you want to, you can change it to an improper fraction. 2 times 6 is 12, plus 1 is 13, so 13 over 6. Again, you don't have to do that, but if it's helpful, you can. Letter J is negative 0.7 repeating. So again, a repeating decimal automatically puts us into the rational category. Letter K looks a little bit scary, but something that you can see or know about square roots is what you can do is you can split this into two separate square roots. So what times itself is 4? That's 2. What times itself is 81? That's 9. So we really have the number 2 over 9, 2/9. So when you have those square roots, you want to simplify the top and bottom both. So 4 and 81 are both considered perfect squares. So that simplifies to the fraction of 2/9, which means this is a rational number. So again, you cannot just assume that because there's a square root, it's going to be irrational. You need to simplify it first. Then we have some questions down here. Which expression does not name an integer? So again, if it's helpful, flip it back over to see what integers are. Positive and negative counting numbers. So this one is definitely an integer. This one is definitely an integer. These two we have to check on. 6 over 14 is not a counting number. Again, just because this is a fraction doesn't mean it's not an integer. You need to see that 12 divided by 6 is actually 2. So 6 over 14 is the one that is not an integer. Number 2, which expression represents an irrational number? Again, irrational means you cannot write it as a fraction. So that one already is a fraction, so we know that's not the answer. Repeating decimals are also part of the definition, so that one's out. So we're down to B and C. When you look at B, you should realize there's nothing that can multiply itself to get 75. So that's how we know this one is irrational. Now D looks pretty yucky, but hopefully we realize that anything minus itself, if you start with anything and take away that whole thing, you are always going to be left with 0, no matter how yucky it looks. Number 3, which number is not a whole number? Whole numbers cannot be negative, so right off the bat, you can find letter B. Again, D looks a little suspect, but 18 divided by 3 is 6, so that is a whole number. Number 4, which of the following is a true statement? So that means 3 of these are false. -9 is a whole number. That is false because whole numbers can't be negative, so that's definitely not a true statement. 0 is a natural number. No, it is not. It is a whole number only. So that one's out. Square root of 25 is an irrational number. Again, we see square root, so we want to just assume irrational, but we can't because 5 times 5 is 25. So that actually is 5 is an irrational number. That's not true. So we know we have D as our answer. The reason is 2/3 is a fraction, which makes it a rational number. Number 5, which of the following statements is false? All real numbers are rational numbers. Okay, well, it's going to be helpful to look back over on the front. Real numbers already get broken down into irrational and rational, and then all these other ones. So all real numbers are not rational because we have all these examples over here. So that one is already false. Let's just go through these to make sure the rest of them are actually true. All natural numbers are integers. So again, this one you can look up here. Here's the small natural number circle. It is within the integer circle, so that one is true. Every integer is a rational number. Same thing. Here's our integer circle inside the rational numbers. If it's an integer, it is definitely rational because you can write it over 1. Every whole number is a real number. Every number we're going to work with is a real number, so that one's going to always be true. For 6, 7, and 8, usually there are lots of answers you can give. So when it says to give an example, you can just think of one, and you only need to think of one. Now 6 is a little bit different though, because it says give an example of a number that is a whole number, but not a natural number. So if you look back on the front, whole numbers and natural numbers are so close, the only one that doesn't match is 0. So 0 is actually the only thing you could have as an example for number 6. 7 and 8 have lots of different things. So a real number that is not rational. So any irrational number. Again, pi is the one we usually put just because it's something that we're used to. Any non-perfect square root. So for instance, 22. Okay, you can put anything under the square root as long as it's not a perfect square. Nothing times itself gives you the number underneath. Give an example of a rational number that is not an integer. Any fraction or decimal that you can think of would work here. So we could do 1/2, we could do 0.25, 25 hundredths, lots and lots of different things that you can have there.